right, we're in section 6.1 still for the standard normal distribution. This one's looking at interpreting SAT scores. And for part A, what we're going to do is given the two two data values, we're going to find the z-score for those. And then at the bottom, we're going to interpret each one and what each one of their meanings are. Okay, so this one says in 2012, 1,664,479 students took the SAT exam. The distribution of scores of the SAT had a mean of 496 and a standard deviation of 114 points. Let X be equal to SAT exam verbal scores in 2012. Assume here, so they want to basically, and they should have done this here, that the distribution of scores, it should say that it is normal, but that's okay that they've already stated that here with their interpretation that that's what n is, basically iterating that this is for a bell-shaped curve. So we can apply all this stuff here. So let's go ahead and do that for the first. If someone scored here x of 1, if they scored 325 points on the SAT. If we're considering that the mean is 496 points, this one scored below the mean, therefore the z-score is going to be negative. Let's go and make that conversion over to z. We'll take that number, 325, minus the 496, making that a negative, and then we're going to divide that by the standard deviation, which is said to be 114 points. Okay, let's go ahead and do that. So therefore 325 minus 496, okay, is negative 171, and then divide that by 114, and there we go, we got an even negative 1.5, so that's even negative 1.5. Okay, so that's pretty nice there for z, and we want to, later on we're going to interpret that. Let me just jump over here for x2. Someone scores 366.21 points. So then easily z, I'll call that z2, and the other one z1. z2 would be equal to that number, 366.21, minus the mean, 496, and then divide that by, again, the 114 points. And then we'll convert that to z. So let's grab a calculator again. Take the 366.2 minus the 496, and then divide it by 114. So there we get a lot of places to write the decimal. Preferably, we're going to go 4 places there, so -1, but then 4 places after that, 1386. So again, 1386. And that's a conversion for Z2. And in some cases here, like this one's 2 places, but this is a terminating decimal. But at most you want to go is like 4 places for these if they're a repeating decimal. And we'll pick up more of that when we get to chapter 9. Okay, so let's go ahead and interpret those as well for each one of these. We know that if, for that first one, x is equal to 325 points, then we know that the z equivalent for that is -1.5. And this just means that if someone scored, so a score of 325 points is interpreted as being 1.5, or in other words 1.5 standard deviations below the mean. Of 496 SAT score points. So again, that score is 1.5 standard deviations below the mean. The next value for X2 is someone scored 366.21 points. So therefore here we know that Z for that number is negative 1.1386. So this is a little more than 1 standard deviation below the mean. So a score of 366.21 points is, let me back this up because both of those are negative, 1.1386 standard deviations below the mean, below 496 points. So again, you can see that both of those with a score of 325 or a score of 366.21 points, both individuals in this case scored below the mean, and then would picked up with a Z value of a negative.